We're going to spend a day or two talking about capacitors. And so in order to do that, we need to know what a capacitor is. So we'll start there. So a capacitor is a device that's used to store electric charge. So here we have, this looks like a different kind of circuit, right? But it's a circuit. Um, but you can see that it's broken, right? There's nothing in the middle here. And so what happens when I have this at 12 volts and this at 0 volts? Well, the charges kind of rush out here um, to fill this conductor, but they can't get across. But they're still attracting um, across this gap. They're still pulling each other towards each other, right? The negative charges are pulling towards the positive charges. And so it fills this plate here, uh, and this plate with positive and negative charge. And that's called charging a capacitor. The positive plate takes on the voltage of the positive terminal, and the negative plate takes on the voltage of the negative terminal. The capacitor as a whole is neutral, right? This balance out. But the voltage difference creates an electric field that is proportional to the stored charge. So there's a field between here. If I threw an electron through here, right, it would kind of bend that way, just like the parallel plates that we talked about before. Um, and that electric field has a strength that's proportional to how much charge you put in there. If I disconnect this from the battery, those charges are still on the plate. Okay, so they can't get back off the plate. So you've actually got essentially a new storage device, right? You've taken some of the charge from the battery and you've pulled it onto these plates, and you've created a new way to store energy. And these are used in common appliances like hair dryers and vacuums and such. Why are they used? Well, it's a good way to get an engine started, right? It takes a lot of power to get a motor moving. And so say a hair dryer stores a bunch of charge on a capacitor, it can release that charge really quickly to get the motor moving quickly. But it also means that you can have, like if you take your hair dryer and it's not working right, um, and you take it apart and unplug it and you're like, oh, I'm being safe, uh, there might be a charged capacitor in there, right? And if you touch the wrong place, you'll get a, a nice little shock, because you're trying to be a good, recycler, and instead of throwing away your hair dryer, see what's wrong with it. So just, be careful about capacitors. So what is Q a function of? It's going to function of the voltage difference, as you might guess. If you have a bigger voltage difference in the battery, you're going to be able to store more. But it's also a function of the capacitance. The capacitance is a physical aspect of your capacitor, um, and we'll talk about that here in a second. So your charge, uh, the potential charge of the capacitor is the voltage. In other words, this is the battery multiplied by the capacitance. So how do we figure out what the capacitance is? Well, we take this epsilon naught, which is a constant called the permittivity of free space. And then, so this is a constant. This is the area of your plate, parallel plate capacitor, how big your plate is. And this is the distance, right? So if I have a big area, I'm going to hold more charge. And if I have a small distance, the distance between here and there, in other words, if my electrical field is really strong, then you're going to have more capacitance. Basically, that smaller distance you have there, the more those positive charges are pulling charges off the negative terminal and vice versa. And that's why your capacitance goes. So why does capacitance increase with area and decrease with distance? Let's look a little bit at the physics of this here. So this is our equation for capacitance. Remember, this is a physical characteristic of the capacitor. This only has to do with the material, kappa, with the size, and with the distance. Okay. There's two things going on in a capacitor. One, you have a voltage here of 12 and a voltage of 0, right? And so that electric field is pulling charges from the battery, right? Because there's a strong electric field. It's pulling charges onto these plates, and that's what's uh, essentially that's what's charging this capacitor. It's trying to they're trying to get across that gap, right? At the same time, the more positive charges I pull onto here, the more those positive charges are going to repel each other, right? So if I try and push too many charges on here, the repelling uh, the force that's repelling charges back onto the battery is going to be as strong as the one that's trying to pull it towards the negative terminal. And so you're going to reach a sort of steady state where these two things get balanced. If I make the area bigger, right, I'm going to reduce this repelling force, okay, because these charges are going to be able to spread out more. If I decrease the distance, I'm going to make this attractive voltage stronger, right? Because I'm going to make that electrical field stronger, and it's going to pull more charges onto the plates. So that's why A and D are important in the